Welcome to all. I am Surikantante, Assistant Professor, Shiv Shankar College of Agriculture, Engineering and Technology, Mirasgaon. Today we will see about the earthen embankment or earthen dams. A dam may be defined as an obstruction or a barrier constructed across a river, stream or valley to retain the water for making big water body behind. An earthen embankment is a raised confining structure made from compacted soil to confine runoff either for surface storage or for groundwater recharge. These are also used for increasing infiltration, detention, and retention of water to facilitate deep percolation and also to provide additional storage. There are different types of earthen embankment based on the construction method. It may be classified into two main types. First one is the roll fill dams and second one is the hydraulic fill dam. First one is a roll-fill dam. It is constructed in the form of several compacted layers. For construction of roll-fill dam, the earth are excavated from the burrow pit and transported to the construction site by means of suitable earth-moving machines like truck or scrapper. In this type of dams, successive layers of moistened or damp soils are laid one over another. Each layer not exceeding 20 cm in thickness is properly consolidated and optimum moisture content, which is maintained by sprinkling water and compacted by mechanical roller. Only then the next layer is laid. The second type is hydraulic fill dam. In this type of dams, the construction, excavation, transportation of the earth is done by hydraulic method. During construction, a mixture of excavated materials in the form of slurry, that is earth-fill material mixed with water, condition is pumped and discharged at the edges. This slurry of excavated materials and water consists of coarse and fine materials. When it is discharged near the outer edge, the coarser material settle first at the edges, while the finer materials move to the middle and settle there. Fine particles are deposited in the central portion to form a watertight central core. In this method, compaction is not required. There are different types of roll-fill dams. It is further divided into homogeneous type, zone type, and third one is the diaphragm type. We will say about the homogeneous type of roll-fill dam. It is composed of one kind of material, excluding slope protection. The material used must be sufficiently impervious to provide an adequate water barrier, and the side slope must be moderately flat for stability and ease of maintenance. The homogeneous soil material is either keyed into the impervious base or impervious soil material can be placed as a blanket to the upstream slope of the embankment. Here you can see different types of homogeneous earthen embankment of dams. Here two figures are shown here. The first top figure is represented by capital A letter. At the bottom you can see the figure shown by the letter capital B. At the top you can see a homogeneous impervious fill material is used to make the embankment. At the base of this homogeneous impervious fill there is an impervious base. But when you see the figure shown by letter B, the impervious blanket is used at the upstream side of the embankment. The purpose is to minimize the seepage loss across the embankment. So this is the type of homogeneous earthen embankment. Now we will see the second type of earthen embankment is zone type. It consists of more than one fill material. The name itself indicates that it is a zone type, so there are more than one fill material which are used to construct the embankment. It consists of a central impervious core surrounded by zones of more pervious material called as cells. These pervious zones or cells support and project the impervious core. A suitable drainage system is also provided in the form of horizontal drain or rock toe in the dam. Here you can see zone type of earthen embankment or the dam, where at the outside there is a porous pervious cell, and at the center you can see a relatively impervious core. Then transition filter zone are provided there to drain out whatever the water that is flows through this relatively impervious core. It should be safely diverted to the outside without causing any harm to the structure. That's why the drainage system or transition filter zone is used there. So this is the type of zoned earthen dam. Third type is the diaphragm type. The bulk of material used for construction of the embankment is pervious. A thin diaphragm of impervious material like concrete, steel, butyl at center is provided to act as barrier against seepage to the fill. The diaphragm checks the flow of seepage water from the drain. The full diaphragm condition occurs when the upper crest of the diaphragm and the design water depth are at the same level. There are cases when the full diaphragm is difficult to adapt. Partial diaphragm can be adapted in conjunction with the core wall. The core wall usually are made up of earth with low hydraulic conductivity to prevent the seepage loss. Here you can see the figure of different diaphragm type based on earthen embankment. The top figure is showing the full diaphragm type because the height of the diaphragm is equal to the depth of water which is stored at the upstream side of the embankment. And second type is the partial diaphragm type, but in the case of second figure, the impermeable core material is also used to prevent the seepage loss. So these two figures shows different types of diaphragm may be used in earthen embankment. The diaphragm may be partial diaphragm or it may be a full diaphragm. Now we will see about the design criteria of earthen dam. The basic design principle of any water harvesting structures is to produce a satisfactory result at a minimum cost. The design of earthen dam should be done on the basis of following criteria. First condition is the dam must be safe against overtopping during the occurrence of greater inflows into the reservoir. The dam must have sufficient freeboard so that overtopping due to wave action can also be checked. The slope of embankment should be stable. The next criteria is there should be made a provision to use seepage control. Control measures in the body of the dam foundation so that the flow of seepage water may be fully checked. The seepage line should not cut the downstream face so that sloping of downstream side slope may be controlled. The upstream side slope must be protected against wave action. Similarly, the crest and downstream slope should also be protected against wind and water erosion. There should be no direct passage of water from upstream to downstream side of the dam to protect the structure against flowing. The next criteria is the downstream impervious core should be properly drained. by using suitable type of filter material. Next criteria is the whole section of dam should be made of earthquake resistance material. Now we will see about the design of earthen dam. An earthen dam consists of the following parameters for design. First one is the top width, second one its freeboard, next the casing or outer sail, next one is the central impervious core, next one is the cutoff trench, next one is the downstream drainage system.